Welcome back my dear friends and students. Um, a very good morning, good afternoon and good evening to all of you, and this is, as you know, this is the DADM, which is Data Analysis and Decision Making 1 course under NPTEL MOOC, and this total course is for 12 weeks, which is 60 lectures and 30 hours, because each lecture is for half an hour and each week you have 5 lectures and for half an hour each, and after each week you have the assignment. So, we are in the last week and we have already completed 2 lectures for the last week, and we are in the 58th lecture, and I am Raghunandan Sengupta from the IME department, IIT Kanpur. So, if we were discussing, and as I mentioned in the last class or last lecture, about the constraints being probabilistic and how they can be considered. So, I will first come to the diagram. So, the diagram would be discussed detailed. So, I will also highlight few portions and draw a few more diagrams as required. So, this is the diagram which we are considering. So, concentrate on the circles which you have. Circles means I will not highlight, but I will just show it to you. These are the circles which you have. Circles why? Because if considered if they are orthogonal to each other. So, that means x1 x2 are orthogonal to each other and the variabilities are same. So, if the variabilities are same and if they meet in the sense that if you are taking the consideration of the variabilities of both of them, they are orthogonal. So, obviously, it will be a sort of slices taken from a football. Now, as the variability increases for both of them, it will just basically be an expansion and contraction of the football. So, if you take the slices again, they would be circles with increasing or decreasing diameter or radius. That is point 1. Point number 2, the loci or the set of points of or locus of any of the circle would basically be the center in and around which you will cover that probability which is being defined by alpha 1 and alpha 2. So, alpha 1 and alpha 2 in the same case, because they are of the same the variability, they would be equal. So, we will consider in the standard normalized case. Why standard normalized case? I am going to come to that within 2 minutes. So, they would basically be equal, and the concentrics or the circles which you have, not the word concentric, the circles which you have would be of the dimension which will basically consider the variability. Likewise, considering alpha and alpha 2 are changing, but they are the same value. Now, what you do is that as the center moves, so the first, the second, the third, the fourth, and it goes on. So, it will basically be the area over which it will basically be covering. So, obviously, as the reliability changes, the green line, because it will get too complicated to draw, too cluttered. So, this feasible point will shrink, in the sense that it will go more towards the upper portion of the first quadrant, considering that your feasible solutions are only in the first quadrant, such that you will be able to find solutions, but they would basically be more reliable in the sense that the probability of achieving them would be higher or lower depending on the values of alpha 1 and alpha 2. So, if I come to the equations and how they would be converted in a standard normal, considering alpha and alpha 2 are equal for the time being, are like this. So, the probability of the first equation, so is G1, I will not write x1 x2 minus the expected value. So, this expected value is the line which I have drawn in yellow and green color of, I will replace it as E1 or E of G1 divided by the variance of G1. That is, if you basically bring the B onto the left hand side. So, it will be basically greater than equal to B1 minus E of G1 by V of G1. This is greater than equal to alpha 1. Alpha 1 greater than equal to, less than equal to, it will be modeled accordingly. Similarly, so the expected value which you have is the central line which is yellow in color, And the variability which you have, I will draw the variability using say blue color here. If you go back to this diagram, they would be the variability which you would have here, not on the infeasible region. So, higher or lower variability would basically mean the dispersion of the spread is more. Now, come to the second equation, probability of G 2 minus E of G 2, variance of G 2 is greater than or equal to B 2 is brought to the left hand side, B 2 minus E of G 2, variance of G 2, this is greater than or equal to alpha 2. Again alpha it can be less than alpha 2, greater than alpha 2. So, here what are the expected values? Let me draw it using the color, so it makes sense. So, this would be the green line, this would be the green line. So, what are the green lines I am talking about? So, the green lines are this. So, this is the mean value, and if I am talking about the variability, I have to use a color separate. So, let me use the color violet. So, this is the variability, this is the variability, and where does the variability come? So, again in the feasible region they would be variability here. So, more moving towards the feasible region and shrinking the feasible region more on to the upper part. Now, why they have been written like this? So, consider this. So, I will put it equation 1, equation 2. So, that this is 1, 2, equation 1 and equation 2 basically means the constant 1, constant 2. So, I am writing for both of them. So, they are basically the first part, whether you are considering equation 1, equation 2, they are technically z, the standard normal, and whether you are considering equation 1, equation 2, this is small z. So, what you have for both the equations, now I will remove the subscripts of 1 and 2. So, it will you will understand the general equation would hold true for both of them, just add subscript 1 and 2 depending on what the problem or which constraint it is. So, it will be probability of capital Z greater than equal to small z is greater than equal to alpha. So, this is your general equation. I will highlight it using the red color. So, they would basically be a standardized formulation, and you can basically have it accordingly. Now, the beauty of this method is that you can work on the optimization problem or from the statistical point of view in two ways. Number one is either keep the circle fixed and basically expand or contract the feasible region such that it is tangent at the point where alpha value is exactly equal to the area being converted in the circle. That is point 1. Point number 2, keep the line fixed and contract and expand the circle. So, the contracting and expanding the circle would basically give you the overall coverages which you are going to have in trying to basically find out the feasible region, the part of the feasible region which will give you the best optimal so called optimal solutions in the non-deterministic case depending on the values of alpha. So, alpha values or expected values are not with the subscript now for our understanding. So, it is like this. So, in the first case, yes. So, you have the so called feasible region and there is a circle. Circle is basically the circle depending on the values of alpha. So, what is happening is that you are slowly moving depending on the value of alpha, you are slowly moving the shifting the deterministic one going towards such that it will be tangent at the point. So, that tangent value where it will be tangent for both the values will give you the optimum solution in the non-deterministic case. How? So, this is the movement of function 1 or which is related to the g 1. Similarly, you will have function 2 which is g 2, and I should have used, let me use that different color. So, it will be easier for all of us to understand. This was in green color. So, that was function 1, sorry. So, this would be the actual point. Now, it is moving. So, this is f 2 or g 2, and this is moving depending on the values of alpha. Alpha I am using the same value, which is technically alpha 2. Now, when I come to the equation 1, these colors would change here, they are yellow in color, remember. So, this was the point. So, they would now be moving. So, consider this is again tangent. So, this was tangent, this was tangent. Now, initially you had the deterministic solution. So, these were basically f 1 g 1. So, it is yellow color is a little bit light, plus please bear with me. So, technically this was the point A for the deterministic one. So, as you move out, this becomes A 1 as it's shrinking, the combinations, this becomes A 2, and the final solution based on this will basically be A 3. So, obviously, in this case alpha is not applicable. In this case it will you will basically have alpha 1, alpha 2 with a certain value. So, let me denote it better with suffixes. So, this will be alpha 1 comma the first value for the first level, alpha 2 for the first level, then you have alpha 1 2, alpha 2 2, and finally, you will have alpha 1 3 and alpha 2 3. So, these three values 1 2 3 would depend then on the region. So, technically you would have circles like this. So, in this case it will be a circle going like this. So, I am trying my level best to draw the circles. So, they would basically the locus would be moving in this direction. Now, what happens if it is a non-normal distribution, which is more important for us to understand, and we will try to draw it. Solution methodology would be a little bit difficult to concentrate and find it out in this course, but we will try to do something in the DADM course, DM2 course, which is to do with reliability, optimization, all those things. But this is a very interesting topic, and if you do any type of problems of robust optimization, reliability programming, stochastic programming, they would give you some ideas how it can be done accordingly. So, let me go to a blank slide related to non-normal and any arbitrary distribution. So, let me draw it first. So, these are so I use the color scheme same. So, there is no confusion. The first value, the second value, and I will draw the mean values are moving. So, now they are all bold in order to make you understand. So, this is the mean value is moving depending on the reliability available. So, they are parallel, and this is the mean values are moving. Now, the points are these. So, 1 1, so it will be 2 2, 3 3 2, 1 2 3 4, and the 5 1 2 3 4, this is the fourth one, and there would be another line. So, this would be the fifth point. So, this is how it is moving. Now, concentrate, I will only draw one diagram in order to make you understand. Now, consider it is non-normal and obviously, it is any arbitrary distribution, both the f1. So, let me write down also. So, this is f2 or g2, this is f1 which is g1. So, now the overall area would be a distribution where the center of gravity would basically be the point which will give me the loci of how the area would be covered, such that the value of alpha and alpha 2 whatever is to be required depending on the of level of significance would be the overall area which is being covered inside that so called non-normal distributions. Now, trying to find out the tangent points. So, tangent points being this or this, based on which we are able to find out the center of gravity. So, tangent points let me denote as, say for example, A for f2, A for f1. Trying to find out would be difficult. So, we will basically use different type of simulation techniques to find it accordingly. Now, if you remember that I did mention that the level of the significance which we consider alpha 1 and alpha 2 would be concentrated on the overall area of covered inside that non-normal distribution. I also mentioned that if, say for example, the errors are dependent on each other, and that would basically have an effect on what is the shift of these yellow and green lines, because that would be dictated by whether the errors are independent, point 1 amongst themselves, point 2 is that whether the x values, which is in this case x 1 and x 2 are dependent amongst themselves, or whether they are affected by the error terms also. So, let me draw or take another blank slide. So, for the error terms, so what will I will draw, I have drawn it, but I will just draw it again. So, let me draw the diagram 4 panels. So, in the first case, the mean value and the standard deviations are fixed. In the second case, mean values are not fixed, standard deviations are changing. In the third case, mean values are fixed, standard deviations are changing, and in the fourth case, both of them are changing. So, I will basically use the red color to draw it. In this case, mean values is increasing, consider. So, I will use the same color scheme everywhere. So, variance is same, mean value is same, but the variance is increasing first, and in this case the mean value is also decreasing and the variance is also increasing. Now, how would they look, and that obviously that would have an, we have done this, I explained that how it will have a consequence on the calculation. So, in this case the mean values and the standard deviations are same. So, there is no change. In this case the mean value is increasing, but standard deviations are same, no change for the standard deviation. In this case mean values are same, but the standard deviations are changing. In this case the mean values are decreasing, increase decreasing does not matter. So, whatever, and the standard deviations are also changing. So, if you have this type of diagrams, so obviously they and the issue is that the reliability so called optimization concept or the diagrams which I shown to you is only applicable for this case. So, obviously, if they are changing, it will have an effect accordingly. For mean values changing, obviously, it will mean the shifting of the boundary. For the variability changing, it will be a little bit more difficult to understand, because if you remember, variability both being same and normal distribution, you basically take slices which will be basically the case for, or like taking slices of a football and then expanding and contracting, the loci would basically be the center of a circle. Now, in case if it is the variances are different, mean values are same or not same, let us not consider it now, then obviously they would be, as I said, the slices of a rugby ball or American football ball, and you can take the slices depending on whether the major axis and minor axis are. It is like you will basically get ellipses, major axis and minor axis being along the x axis and y axis, depending on where the variability is high. So, if the variability for x 1 is high along the x axis, so you will have the concentric values would be like this. So, it will be more along the x axis, less along the y axis. Now, in case if the variabilities are just the reverse, you have more variability along the y axis, less along the x axis, it will look like this. So, obviously, your the loci of the center of gravity of the center of the ellipse would move in such a way that the overall area covered in that ellipse or in the circle would basically be the one corresponding to alpha 1 and alpha 2, which you have found out. So, alpha 1 and alpha 2 in this case would be different, because alpha 1 and alpha 2 were same when you had the concentric circles as you are taking slices of the football. Now, in order to solve this, there are different type of methods from the optimization case. So, generally it is done in a way that you basically simulate. Simulate means the number of times it is applicable, and based on that you basically find out in the case that how many such values either are above or below this point of B1 or B2, depending on which constraint you are considering, and based on that you find out the level of significance between alpha and alpha 2 and solve the problems accordingly. We will we have different type of methodologies to solve. So, generally the methodology which we consider is twofolds. First, we see what type of structure of the problem it is. If it is a simple optimization problem, or either the integer programming, mixed integer programming, whatever it is, these are also very heavily used in statistics, that is why I am mentioning it. So, you will basically solve the problem using the optimization method which you have, and then use the reliability problem to basically search the space to find out, say for example, capital A1, capital A2, capital A3. So, this capital A1, capital A2 and capital A3 are the deterministic solution considering the reliability is changing. So, first solve, find out capital A1 or capital A2, capital A3 depending on simple optimization problem. Then what you do is that basically you try to use the reliability model to find out the best possible point from utilizing this A1 and A2, such that the distance moved from A1 or A2 or A3 as the case may be would basically be the smallest distance in order to basically reach the tangential point of the circle or the ellipse, whatever it is. So, you keep repeating it, first find out A1, then try to find out the optimum point using the tangential concept for a circle or ellipse. Then finding out the tangential point, you basically go into the next step, again try to optimize and find out the best possible solution of A2, and then again find out the tangential point. Keep repeating it till you are basically certain that there is no such further improvement in the solution within a certain bound. So, in the simulation case, and then you basically report that value as the best possible level of solution, depending on the level of alpha 1 and alpha 2, which has been basically decided by the person who is doing the optimization problem, and when he is trying to basically solve it. These are blank slide, I will just skip, and I will come to the structure equation modeling concept. So, given a path diagram basically means the relationship which you have between the explanatory variables and the independent and the dependent variables. And remember that explanatory variables can be the dependent variables in the next set of equations in the structural equation modeling case. So, given a path diagram, write the model equations and say which are the exogenous variables and how they are correlated with each other, and the correlation coefficient can be found out using the simple correlation coefficient matrix. So, given the model equations and the information about which exogenous variables are correlated with each other, you basically again draw the path diagram. So, first you basically define the relationship, draw the path diagram and proceed accordingly. So, given either piece of information, write the models in matrix form and say what are the matrices based on which you are trying to basically optimize. So, this matrices would give you the type of equations which you are trying to find out, and also try to find out what is the maximum amount of variability or maximum amount of relationship you can find out using this path diagrams and finding out the equations which are there. You calculate the model's covariances, because covariance would definitely give you the level of significance which is applicable, and you will check the identifiability of the problem, try to find out whether it is feasible, and then basically comment accordingly. You will go step by step. As the variability changes, you will basically report the answers and find out the relationship at each and every step, what are the exogenous variables, what are the independent variables, what are the dependent variables, and basically say that how the overall path diagram of the interrelationship is there. For each different set of equations, as I mentioned and I did mention it twice, the level of significance will change, point 1. Point number 2, it will also matter that how does the explanatory variables and the levels of the independent and the dependent variable structure change. So, because that will have an effect on the path diagrams, the relationship, and in which way the arrows point, and it will also give you the level to which the dependent structure is basically being modeled using the covariance variance matrix. So, with this I will end the lecture with 2 lectures still left to end this course. I will try to basically wrap up the structural equation modeling, and if possible in the last lecture give you an overview what things we have covered, and there are a lot of things we may have not have covered, but I will basically still try to highlight that considering the overall coverage where you can basically concentrate on and basically look into the and other topics, and if you find any interesting one, you are most welcome to write us on the forum and we will reply. And obviously, it will matter that if you go these are notes or the slides which I am teaching are not the overall concept which would basically make one person master in statistical methods which are required, but obviously a little bit practice, little bit reading would make things much better for on your part, such that if you solve the problems what we have done and lot of cases we have solved, or the assignments we solved, it will definitely clear many of the doubts which you are facing, and obviously practicing would make things much more better and much more perfect for all of you. With this I will close this class and have a nice day, and thank you very much.